I think all three of these to some degree apply.
But if you just have a blue and a white, you still have a 1 and a 0.
Well, yeah, you know, whether or not it's not binary is a different question, right? Whether the computational technique is different than digital because it uses a different medium really relies more on whether you're binary or not, right? So when you go to quantum, you're not binary. Well, some of the quantum stuff is binary, but most of it isn't binary anymore. When we go to quantum computing, it probably changes all of the rules, right? When you just use a different medium, for instance, molecules instead of silicon, you're right. If you're using blue-white, it's still binary, and it's still a lot like the computing that we're doing now. So we'll see how that goes over time. Right? It's not altogether clear how that's going to develop. But raises the stakes on medium and the message. I mean, regardless of which of these it fits in, biological molecular computing, for example, as in nanostructure computing, as in DNA computing, as in quantum computing, will all change, we think, the package altogether. We're going to come to this a couple times in the course, but just as a place to start, we are etching chips on silicon, essentially. There's a couple other ways to do it, but still, you know, we're scratching holes in silicon chips, okay? And then we're limited by the mechanics and the electromechanics of what can be done within that space. When that changes, then it isn't like all bets are off, but the stakes on the table change altogether. And then we may have to go back and recast the whole thing, okay? Because when we're not dealing with the medium, anything like we understand it now, and it changes altogether, then who knows what the relationship between the medium and the message is. We may have to recast the whole thing. Okay? But that's down the road a little bit. We'll come to concepts about that in just a little bit.